Hello, I'm MC Toon, the worst rapper in the world. How are you doing tonight? It's exciting. We're getting towards Christmas. I've got the whole place decorated. My mom, I saw her yesterday. We went and saw her, and we stayed away. We didn't get close, and masks were worn. But she gave me this shirt here. It's got a flat Earth on it as a joke. Thanks, Mom. Love you. If you're watching. So, all right. What's going on? I've got Brian Leake on deck here. He's I think he's trying to connect right now. I sent him the link, and he did not have Zoom installed before, so he's got to install Zoom now. So okay, I'm looking at we Jerry 1SM is talking about a particular video by Mark Steele where he's making an accusation toward me. So I did watch that. I don't know if he's specific. I'll watch it again to see if he's making a very specific allegation so I can add it to the complaint I'm sending to the police. Speaking of Mark Steele, tomorrow at 4 p.m. Central Time, 10 p.m. UK time is my Christmas special. I'm looking forward to this. It's going to be very awesome. I've put a good amount of work into it. It is Mark Steele's 12 Lies of Christmas. I put together supercuts of several of Mark Steele's different claims that are really crazy. I bet you can all guess at one of them in the chat. I bet we'll see what they say. Anyway, that's going to be exciting. I'm going to have several guests with, and we're going to just people that understand, the technology that Mark pretends to understand but doesn't. So it will be very fun. Bring your ugly sweaters, Christmas hats, whatever festive attire you have. I have in fact invited Mark Steele. I sent him an email asking him to come to wear festive attire, of course, and being that he is the guest of honor and it's a Christmas special, I said, well, you should have the honor of singing the Christmas medley. So I asked him for that. I haven't heard back. I'm sure he'll be there with his Christmas medley ready to go. Now, don't tell Mark, but I sent an email to his twin brother Graham as well. Mark doesn't know, right? Asking Graham to come wearing the same outfit as Mark, and they can sing the songs together, and they'd be twinning, and they're twins. It's gonna be great. I'm sure that they'll both make it. I mean, why would they not, right? But what I'm gonna do is I put the email that I sent to both Mark and Graham on the Discord server. It's scrolled off by now. I'm gonna tweet it. I'm gonna put it in the Discord server where it won't roll away, and you can look at it. So. Still nothing from Brian here. I have Zoom up, nothing in there. I don't have the waiting room on, so he can come in whenever he wants, and I'll hear it right away. So, lucky you reminded MC Toon about that. We wouldn't want that to happen by accident. What? Perfect sweater? Is he? He's not in jail. He was arrested on Saturday and then promptly released. He did a video Saturday after, I don't know what time he was arrested, but later Saturday a video showed up of him because he's so good at technology. There was a video of him getting arrested on Instagram, and rather than download it and put it into a video and play it, he took his phone and filmed the screen of Instagram playing the video because he's so good at technology. No, he's not. He's terrible at technology. So anyway, where's John? John is, I was pretty sure that Brian was going to be here on time. So I didn't ask John to show up, but since Brian isn't here, I mean, maybe we can have some comic, oh, look at that. Skydiver Tanner has a hideously ugly sweater that he's going to be wearing tomorrow. So that's awesome. He sent it to me on Discord. Yeah, Rapid X is here. How you doing, man? Well, Did I ever find Eric? Asks Citizen 9. Eric Dubé. No, he's missing or something. I don't know. Ooh, we have Brian connecting in. We shall see if that'll work out for him. So I don't hear anything yet, but he has connected on Zoom. Yeah, he's got no audio. He's trying to connect to audio. So good. There we go. We've got that, and I'm going to get it so that he shows up just fine. I think he's going to be on camera. We'll see. I know he's been on camera before, so it won't be the first. So, have I seen the Eric Dubé movie trailer? I have not seen the Eric Dubé movie trailer. That sounds... Is it comedy or satire? Because that would make sense. Man. Let's see. Oh, we did have a couple. We had 2 super chats early. People they wanted to get their super chats in early. So we got one from Area 85 Restoration says, I'm here to laugh at flat earthers and eat popcorn, and I'm all out of popcorn. Thank you for that. Area 85 Restorations. We've got Conical Reason upgraded his membership. Thank you for that. And ooh, I'm hearing Brian.
Yeah, I'm here, buddy. I need just a minute to sort shit out, bud. All
right. Man. And then we got one more. Where'd it go? Where did it go? We've got Alyssum for $2 says, litmus test, does he have a functional flat earth based map? Excellent question. I'm sure he will. So he's I don't know, is he going to be on screen? It's a movie that Dubé is producing and directing, not sure, called Level. Oh my goodness. That sounds like satire. I'm sure it's satire. So got my not tab there. And then should I need it, I can call on the open tab right here. Will I be doing more videos on Simon Perry? I doubt it. He's no good at debating, because all he does is say, you're dumb if you don't think it's flat. That's it. That's the essence of his argument. And he does it on Facebook as well, and then posts a meme. And you ask him a question, he posts a meme on a different topic. He never answers anything at all. So, in fact, he says it's just Eric reading his 200 proofs. Didn't he already do that in a YouTube video? What's the difference between that and a movie? I don't know. So, well, here we go. QTube for $2 says a flat earth is only functional as a beer coaster. True. So, we've got Wacka Troll 33 showed up, and I don't know what Brian is doing. So that's all right. We can still go on. Graham Price says Simon Perry isn't worth engaging with. He's completely and utterly brainwashed. He is. I don't know what it like. He talks. He's like, you're pseudoscience. I'm like, well, can you please explain what you mean that is pseudoscience of what I presented? And he doesn't. He just changes the topic. So it's not a very fruitful conversation, is it? It's not even a debate. It's just him just saying the same thing. You're dumb if you don't think it's flat. That's all he says. So anyway, we've got Conalex Silver Fur for a $1 with no message. Thank you very much, Silver Fur, Mr. or Mrs. or Ms. Silver Fur. So he only said one sentence and he already swore on my channel. I know, Brian, watch the language, man.
Yeah, I watch the language. How's my audio, man?
It sounds fine. Are you going to be on camera, or is it just going to be your voice?
Man, I'm kind of shifting and shuffling a little bit, so I'll go on camera here in a little bit.
Okay. Are you ready to talk, or should I keep chatting?
Yeah, I'm ready to talk.
Okay.
just for your audience sake who doesn't know me, I mean, I get a little passionate at times when I'm interrupted or insulted. You know how it is. Pretty normal, down to earth, one-on-one. And I was gonna just, I'm a father of 6, hardworking, 6 grandkids, and I'm not 100% on anything. I like to keep a peace of mind. I think I'm leaning toward the flat Earth. I've been debating for the flat Earth for a long time because I think it's interesting. And but if they could prove it's a globe, I'm not going to ignore that evidence. I mean, I want to see proof, and I think there are some ways they can do it. Right? In my opinion, there's ways they could absolutely prove it without NASA, without Eratosthenes and shit like that. I think there's ways we could prove it, but yeah, I'm on the phone, so I don't know if I'm gonna be able to pull anything up or send videos at the moment, but we could just keep it gentleman and go as common knowledge basically if you want. But I might have to cut out after an hour. If I do and everything goes good, we can finish up next Tuesday or whenever. That's it, man. That's basically
all right.
My introduction.
Okay. Well, ow. I just, I don't know if you see me. We had tacos for dinner, and I cut up the jalapenos. Okay.
Get the wet wipes.
And I just rubbed my eye. So, that's lovely. So good. People, remind me not to do that again.
MC, I've watched you, man. I've been debating this for, I guess it's about, when was the North Carolina Flat Earth Conference? Like 2017 or so?
Yep, because it was North Carolina, then Denver, then Texas, then back to North Carolina for just the one that Karen B did in October.
I think that was South Carolina, but yeah, you're right. Okay, that right about a month or two after that, I looked into it, and I always had a itching problem, like in the back of my head, and this is room for debate too, with the rockets working in space. I'm sure. I mean, I don't completely buy what they say, but I don't 100% deny it. But it's just it doesn't quite make sense to me. It never has ever in my life.
That what?
And about rockets in space. Have you ever contemplated that, when you were growing up as a young man?
Yeah, as a kid, when I didn't understand the laws of motion like I do now, I was curious about it. But the Newton's third law of motion, every action there's an equal and opposite reaction, right? So if you throw something one way, you go that way. Tommy Gronwald.
I understand that. I'm good with that. Yeah, go ahead. Bye-bye.
Okay. If you know Tommy Gronwald, he has a video where he gets on a chair, and that's a swivel chair, and I think he moves his arms or he moves a weight, but he's not touching anything. His feet are up off the ground. He's moving that back and forth, and he rotates when he moves it. That's a good demonstration of it.
I'm going to come on video and show you why I don't think it would work here shortly.
Okay.
But I'll say this, man. When they started talking about this is when I was a young man, nothing having to do with flat Earth, just something that I kept to myself. Okay. And they said, when they started talking about having to use the planets for slingshotting and stuff like that, and I was like, oh, okay, well, that makes sense. So in other words, they have to do this strict math and hit a planet's gravity and do a loop at the exact calculation so they can exit out of that loop going in an exact direction. So they had me on that. I was like, okay, I'll accept that. But as far as steering goes, and I assume we went to the moon. I'm skeptical now about it, but I was like, here's the frame of mind I had. Dude, they got moon bases that they're just not telling us about. They better, dude, we went to the moon in '69. So,
well, of course
we have all that.
There's an annual breakdancing competition that NASA hosts on the moon in April every year. Did you not know that?
But anyway,
so this last year, Simon, Dan, and Neil deGrasse Tyson were in the finals, and Dan destroyed Neil. Neil broke his hip.
I bet.
Yeah.
That was my frame of thought anyway. That was my frame of thought before I heard anything about this. Is I just assumed that of course we're on the moon. You know, I mean they're not going to tell us all the technology, and they went in '69, so we got bases. I would almost bet on it. That was my standing before I heard about the flat Earth stuff. But I did have questions about what was going on around me. The sunset never made sense. The way it sat on the horizon. But you know, there's a good explanation for that. But so I'll start with this. I'll say that you know, when I heard about the flat, I want to feel you out because we've both been doing this for a long time, and you're good at debating. You're factual. You bring evidence. You know what I'm saying? And I'm sure you've heard good evidence for the flat Earth. Would you? But I want to see where you're personally coming from. Would you concede that it's a good debate? It's a fair, fun debate?
Oh, absolutely. I enjoy it. I do it, you know, just about every week. Yeah.
So you do enjoy it. Yeah, good. Because some people say that flat earthers are stupid and it's not even worth debating. And I'm like, you know, well, why are you debating it? You know, if you think they're stupid. And I don't think that the people arguing for the globe are stupid. I don't think I'm sure there's dumb people on both sides, but yeah, I think it's an interesting debate, man. I think it's awesome. One other thing, what's your percentage, man? If you ask me, I'm gonna say I'm 99% flat, but I'll reserve a 1% because and what's your percentage globe, man? Is it 100 or 99.99999?
Well,
what are you?
To be, you know, pedantically correct about science, you're never 100% in science, but I don't have any doubts. There isn't anything that I've seen that would work for flat Earth. There's so many things that absolutely you'd have to reduce all of physics and science and all of our understanding for flat Earth to work. So I don't have any doubt. So I won't give an absolute, but I would if I were a betting man, I would freely bet an awful lot.
I'd bet half the farm. Okay, so that's where I'll go is physics. But one more question. This is my third question. Hold on one second. Okay, so with everything you've learned, and you seem educated, do you question anything about mainstream? And I'm not talking about conspiracy. I mean, you could go that route if you'd like, but do you question anything at all, like anything you taught where you think maybe we could do it better, maybe the information just ain't quite right? You think anything you learned is false? Any of your teachers ever taught you?
Oh, yeah, sure. There's plenty of. I was told, I was probably about 5, by an adult that said that the reason why gravity works is because the Earth is spinning, and if the Earth did not spin, then we would fly off. And as a 5-year-old, and I know how old I was because I know what house I lived in, and I know how old I was when I moved out of that house. So no more than 5 years old. I heard that and I thought that doesn't make sense at all. So yes, I have heard things from adults teaching me that were wrong. Everybody gets things wrong, you know, even me. I'm sure if people were to watch all of my videos, you might find maybe one thing wrong. Maybe. I'm kidding.
So we'll go with that's a good
I'm wrong
answer,
plenty.
man.
I'm wrong plenty.
Yeah, but that's a good answer as far as because I can relate to that because I moved. We moved when I was right before I turned 5. So, and I'm fortunate that we moved right then because that's right when you start getting memories, you know, a year or two before that. Yeah. And so it was like 4.5 years old. So every memory that I have before this house, I know I was at least just turned 4 or sooner than that. So yeah, I can relate to that, man. So I'll start with the physics, with my questions in physics. And I will say that, I mean, there's a couple things that I come here strictly to learn. And I'm going to bring contention. Don't worry. And I could get passionate, but I do have a couple honest questions that and if anybody's got the answer, I know you would. So, but first off, so with the first law, okay, so an object in motion stays in motion unless acted on by force. So
Yeah.
so if an object is in motion and it hits another object, so basically, matter is force. Would you agree or disagree? And what would be your explanation?
Matter is not force. No.
Okay, so we have to update that saying. And so if an object in motion will stay in motion unless acted on by force or hitting an object.
Yeah, when it hits an object,
Right.
there's forces between the objects that happen. Right. We can calculate how much force is being exerted the other direction. So if you have pool balls are often used because they're very they bounce very nicely against each other, right? So you hit one with the other and you can calculate how much force the other one puts on it. You take its resting mass and then you figure out how much it's going to be accelerating afterwards. So anyway, that's not in question. I don't really know what you're getting at there. Can you hear me? I don't think he can hear me. I saw him. So I oh, there's two of me. Look at that. He dropped out. So yeah, all right. Conalex Silver Fox says tuned out of the globe when he was 5. I did not. I doubted that person's explanation of gravity being caused by rotation. That was a problem for me. And so I'm like, well, glad I kind of got that figured out. Let me read a couple super chats while we're waiting for Brian here. Did you all see something go goofy? Because my screen went wacky. So, all right. Wow. We've got Brian's reconnecting to audio. Where'd it go? Dingo for $5 Australian did not say anything. Thank you, Dingo. And same for Alyssum for 5 Australian. I appreciate both of you. If you have a message, go ahead and send it to me. Brian Peck for $2 says Leake debates against reality by asking for stupid. Brian, was that intentional?
That's funny, man.
Was that intentional grammar on his part, you think?
No, because look, man, I'm the type who is realistic, and I mean, I'm not the type who thinks anybody's stupid for believing in a ball, because the model's good. It's currently, I'd say there's about an equal amount of good questions on each side. But at first, the globe model dominated. The more we learn, I think the more, there's some pretty good arguments for the flat Earth. I've got a couple new ones tonight for you, because I don't want to read down the list, man, And
yeah, I'm always ready for new ones.
I got one more thing I need an explanation for, because this is an easy one, man. It's probably an easy answer, but man, I've had problems with this since I heard that 9.8 meters per second square. So I did a little video. If anybody's, it ain't many people, but whoever has watched my video knows I'm hands-on. I like to see shit for myself. I like to see it, and I like to show things, which ironically I'm not doing tonight. But they said that the only difference when I drop things is wind resistance, right? So, and I did an experiment in like the 7th grade, and it was one of the ones on the list where you drop a ping pong ball and a golf ball, and you record they fall at the same rate. So I've seen that, and then I've seen some videos showing different elements and vacuum tubes dropping at different rates, and it wasn't much, but it was just a little bit different. And I don't know if they were doing the math on that. I don't know what the explanation is. I wouldn't say it 100% proves it, but it can't be just wind resistance, because a golf ball and a ping pong ball are the same size. I had them the same size. And then a guy said that, the golf balls got dimples. It's more wind resistant. So I took my grinder and grinded the freaking dimples off just to make sure that wasn't the reason. And I just climbed up on the roof and made just a 1-minute video where I dropped the ping pong ball and the golf ball. And every time I did it, the golf ball hit first, every time without fail. You see it accelerating past the ping pong ball. And then I came back and the guy said, well, he said, that's because it's lighter. And I said, no shit. He said, no, he said, he said, it's less dense. And I said, yeah, go ahead. And I said, no shit. Right.
Yeah. So wind resistance is a thing. And actually the dimples in the golf ball reduce wind resistance by creating eddy currents inside those little dimples. And so rather than the air rubbing against the surface of the ball, the air rubs against the air pocket eddy, the eddy current that's going inside that dimple. So there's less wind resistance from or air resistance in a golf ball. But either way, a golf ball that's got dimples or not is definitely going to fall faster than a ping pong ball because of wind resistance. So I don't know what the challenge is there. That's what we predict. Are you still there? You went silent.
Hey, sorry about that.
Oh.
So yeah, I'm glad we're being gentlemen because I could plug in my grinder and let you hear it. But yeah, so you said either way it would hit quicker because I have some. I took some little compressors out of. I took one of them out of an old air conditioner, and I took a couple of them out of an old refrigerator, and I've messed around a little bit. But I can't. I need to get some clear tubes because, of course, you can't make a vacuum chamber, big enough to prove anything when it comes to that. But maybe with some thin tubes, but I don't have no clear tubes. But I'll say this: so to me, in my world, relative density is a perfect explanation, man. And it always boils down to this. At just the same time, we'll say this. I'm going to say that air has no mass. Okay. And you're going to say whatever, but, and I'm going to, we all did the experiment where we weighed the balloon on the balance beams at school, and it weighed a gram or two. And then we blew it up, and then we weighed it, and we took notes of that it gained a smidge of weight. Yeah. Right. And that's the argument that air has. I'm not doubting that air has mass. I'll drop a bombshell on you.
Yeah, that's kind of crazy. It has mass, right? We know enough as people about matter, right? Air is made out of matter, nitrogen, oxygen, carbon dioxide, and each of those things has mass. And if you did titration and different things in chemistry, you can actually quantify the mass of different elements, and people have done that to great precision. So we know how the mass of an atom of nitrogen, and there's nitrogen in the air, and so there's mass.
Yeah, but even in chemistry with the titration, you could argue that the redox. I don't know, man. I mean, we could go all night about chemistry, but let's say this. Okay, so you would say that gravity does act on air. Ain't that what it boils down to in this debate? Is whether gravity acts on a
gravity.
gas?
Gravity does definitely make it pretty impossible for the Earth to be flat. So yeah, a particle of air accelerated up will slow down as it moves up, and eventually, unless it's moving really fast, eventually it will slow down enough that it'll turn around and come back. Of course, there's other molecules that'll hit on the way, so they don't generally get to just have a free shot up,
It's fair enough answer. So here's what most people do in this argument, man, is they like to go. Oh, wait, one more thing. Would you? In my mind, and am I wrong here? Relative density. I'm not talking about buoyancy because that has G in it, but relative density does explain everything we see at all ever. So if you're just looking on the...
So where is the direction of acceleration in relative density? Because things go that way.
Depends on your...
Things go that way.
Depends on... Yeah, exactly.
In
Like
the room I'm in,
things go to equilibrium. That would be my answer.
yeah, well, in the room I'm in, the air pressure is lower this way. Lower up and higher down. So if it's about relative density, then if I were to drop something or let go of something, it would go something that's denser than air. It would go to where it's less dense than air. This way, it'd go up. Not
I would argue
down.
that it's going to go back where it came from.
No, I put it over there. That's where it came from. But if I drop it here, it's going to go there, not over to where it came from. But just saying it's going to go where it came from doesn't quite work, because if I take this Sharpie and I set it on a scale, I can still measure the force that it's pressing down, and the force is directly proportional to its mass at 9.8 meters per second squared. Right. So
that's where I wanted to get to.
Force
Okay.
Force is, so let's cover what force is. Force is mass times acceleration, those two together, right? So kilogram meters per second squared.
M2 over R squared. I'm
No,
that's
that's the equation for
You're
gravity.
talking about
That's
9.8
not
meters. You're talking about F equals ma. I know what you're talking
There you
about.
go.
I was
Yeah.
just trying to bypass.
Yeah.
But listen, so people like to start off in space. So you say air has weight. Okay, instead of starting off in space, okay, let me tell you why I know relative density is all there is. There's no gravity, okay? Because they try. Okay, so let me say this hypothetically, okay? So take a vacuum chamber, okay, and take as much out of it as you can. Period. We got the biggest, best vacuum chamber on Earth, not in space, on Earth. Okay, so there's 0 liters of gas. It's 100. Let's say it's 100-liter container. Okay, add a half a liter of gas. Is it going to go down, McDoon?
It will distribute mostly evenly, but it'll be denser near the ground than at the top.
Okay, so if you wanted to put that in a balloon, they say the balloon will go down. Yeah, because the balloon has mass like helium in a vacuum chamber.
Yeah.
But let's be honest, the balloon is still inflated, and the balloon will push equal and opposite on every end of that balloon. So before you just go giving a quick answer, I mean, think about that. It's not going down. There's no downward bias for gas, period, in my opinion. It's going to blow on that balloon equal and opposite. So if you had a vacuum chamber,
But in the what direction
Yeah.
does the balloon go in the vacuum chamber? Up or down?
The balloon goes down, but the balloon goes down, but the gas is still blowing it's still blowing the balloon up. In other words, the balloon don't deflate toward the bottom. You see what I'm saying? So there's no way around that, in my opinion.
As predicted by what we understand about physics, it will press in all directions. I don't understand where you're getting that it has anything to do with it. The other thing is if you take this marker here and you put it in the vacuum chamber before you evacuate the air, and you measure its mass or its weight, measure its weight, and then evacuate it and then measure its weight again, the difference is extremely small. And the amount of difference between the weight before and the weight after, we can calculate using the buoyancy formula. How do you explain that difference in the downward?
I would argue that, man, why do you even need the buoyancy formula? That's like a whole extra formula as to what we need. So something's wrong when you have extra mass. Yeah, I agree that it works.
It works.
But
That's
when you
why.
have extra equations, in my mind, I'm just saying in my mind, things get suspicious when you got extra equations. Like, why do we have to do an extra equation for taking something or something going up? You know what I'm saying?
The universe has no care about your opinion on whether or not it's complex or not.
I get that.
It doesn't.
I get that. But would you at least say that's a little bit kind of, I don't know, like, look, we got this formula and we talk about everything except things going up, which violate the rule in the first place, in my opinion. But to me, it's just a little bit, you see where I'm coming from. I do agree that the formulas work. I'm not going to argue. I didn't come on here to play stupid, but, anyway, I just wanted to give that argument that if you had a evacuated vacuum chamber and you put a smidge of gas in there, it's not going to go down. We all know that, in my opinion.
It does, as predicted, because the air at the bottom is going to be denser than the air at the top.
Well, guess what? You say it will be, but if that would bring it up to like almost, that would bring it up to about space vacuum. Let's just say ISS vacuum area, like 10 to the negative 14th, I think they say, Tor. Okay, so
yeah.
So you'd have such a little bit of gas in there. The way we measure pressure is the pressure is going to be equal down to the sides and up, and that's what the vacuum's laws say. The only way the pressure, if you want to say,
Whoa.
you know, if you want to say,
what's vacuum's law?
To me, the vacuum law. I mean, not the vacuum laws. You know what I'm saying?
The ideal gas law.
Yeah, well, not just the ideal gas law. All the gas laws, in my opinion, they do conflict a little bit, but that's kind of a technical argument. But yeah, the ideal gas laws say that, you know, the only way to change the pressure is to change the volumes or the temperature, basically, right? And so the pressure is it's not pressure downwards as there is upwards. That's my point. And to me, that's a fair argument. But I don't know. What do you think?
Yeah, I think it works just fine. I don't see a problem with it. And just, I don't know what all the gas laws, like Dyson.
I don't know, man. It's just like, well, I was looking, if you'd seen that video, I posted 4 pages from Google. And in case somebody wanted to look a little bit closer, you know, I only had them up as like a little quick slideshow, and they make sense and everything, but you get a little conflicting information on what's going on in the atmosphere. And like I've commented in the video, when I get conflicting information, you know, some of it is pedantic, but some of it, you know, kind of seems conflicting. And the same thing with maps. I was studying maps, just Tahiti last night, and I'm getting different results, like 500 miles from. I'm checking the distance from Tahiti to Florida, and then from Tahiti to Chicago, and then, you know, that argument. And it just seems like there's inconsistencies depending on what website you go through. And to me, that means we're right over. At least we're over the topic of contention when you have conflicting information, man. In my opinion, man.
Could we go over maybe some of this conflicting information? Because I've not seen anything that's conflicting like that.
Yeah, but I got one more question for you, man, because this I honestly wanted you to teach me.
You have a lot of one more questions. Okay, go ahead.
Yeah, I know. No, this was the question I actually hung up earlier before I got to ask you.
Okay.
And but so 9.8 meters per second squared. Okay. I was told that it doesn't work like that, you know, that, so when I was doing the math, I'm just using any, you know, I'm just squaring it. So I'm thinking 9.8 meters per second. So, you know, if you're doing the math by yourself, you just round it out to 9 or 10, right? So 10, and then you say, the meters per second squared. So if I'm going to square the second or the meter, but, or together, for that matter. But if I'm going to square the second, I'm going to say, okay, so 4 times, because I was coming up with that, we're pretty much at terminal velocity in like less than 2 seconds, just under 2 seconds. So in other words, it's hard, in my opinion, to call it acceleration when we pretty much, you know, you're starting from not moving or a change in direction due to relative distance. No, but to me, but I was told my math is wrong. And so if 9.8 meters per second squared, 4 seconds. So if I'm going to square the second, I'm going to say 4 times 4 is 16, times 9 would be what, 144 something, you know, in that ballpark. But I was told that was wrong, that I'm doing it wrong. And this is what I wanted you to teach me. What am I doing wrong with 9.8 meters per second squared?
Yeah. So I don't know what you were just going over there. Hold on. I just rubbed my eyes again. No pain yet. All right, good.
Good question. You know?
Yeah. So in the first second, you accelerate from 0 to roughly 9.8 meters per second. So that's a velocity, not an acceleration. And then let's call it 10 to make it easy, right? And then in the next second, you add another 10 meters per second squared. So at the end of the second, you're now moving 20 meters per second down. And then you do it again. Now you're at 30 meters per second down.
Right. So you don't square nothing. That was my point. Okay.
Yeah,
fair enough. So I ain't retarded.
Yeah. All right. So, it helps if you understand calculus at least a little. Did you do calculus?
I understand a little bit of calculus, but what
did
got me is that
did you take calculus in high school or college?
Yeah, in high school. And listen, I mean, I'm mainly focused on geometry. I know a little bit of trig, a little bit of calculus. I'm not great, but I understand it. Okay. But the thing is like if you don't square like when I hear 9.8 meters per second squared, if I'm not squaring the meter, I'm not squaring the second, and I'm not squaring the meters per second, why the hell do they even call it squared, right? You know what I'm saying?
No. Yeah, I think you're just not quite getting it. And I can explain it to you, but I can't understand it for you. You said you took calculus in high school? I don't hear you again. Like, did you get a phone call? Maybe?
Man, I got disconnected, man. I didn't hear that answer, but
okay.
I apologize.
Yeah, so I think it's the what you're missing, I think, and I think Mute Donkey just kind of did this, and Rumpus is getting on my case. Rumpus, it's 2 a.m. What are you doing? Where'd you go, Mute Donkey? How do you square a unit? That's good. Yeah, you don't square the seconds. You don't square the units. It's how you apply it, right? And so velocity is, velocity is. Here I come, Rumpus.
Sure. I mean,
what's velocity?
Velocity is the rate, right? The rate of the acceleration, right?
But you can.
Why would you ask me something like that? Let's say I didn't know that. I mean, I came here for a gentleman conversation.
Well, yeah, but
and that's why I don't talk to Rumpus. It's because he's so condescending and shit. You know what I'm saying?
You have his. That's why Rumpus is here. It's 2 a.m. Rumpus. I don't know if he's been in one of my later streams ever. So welcome, Rumpus. That must you brought in the Rumpus, Brian. I think that's what happened here.
I brought in the Rumpus. All right.
Yeah. Yeah, here, Justin Franks. Meters per second squared is shorthand for meters per second. So it means that you add 9.8 meters per second every second. You add it every second.
Okay, yeah, that makes sense. Per second, per second. Okay, so that's how, is that how it's written, per second, per second?
That's what the per second squared means, yeah. When you divide again by something,
well, what are they squaring, though?
When you divide,
that's a fair question. Wouldn't you say it's a fair question because they're not really squaring nothing? I mean,
all right. We homeschool our kids, and I'm the math teacher, and so when they're learning algebra, and learning how to do things with exponents, right? So if you have a squared plus a squared, or sorry, a squared times a squared, what do you get?
Yeah, you cancel them. Okay, yeah.
No. You don't cancel. You add. The exponents, right? So a squared times a squared is a to the power 4.
Okay. Right? Yeah, exponential. Yeah.
And the same thing when it's on the bottom when you're dividing by a square, right? So if it's 1 over a squared
that's when you
times 1 over a squared, you have 1 over a to the 4th. But you can also write it as not just 1 over a squared. You can write it as a to the power of -2. So if you multiply a to the power of -2 times a to the power of -2, you add together those exponents. -2 plus -2 is -4.
But it's still written. It's kind of stated as a multiplication, though. I mean, in my opinion,
it is.
That's a good answer, though. That's a good answer.
This is, I think, somewhere between 6th and 8th grade is where we cover that.
Oh man, really, dude?
I
really. So you're going to put it in multiplication forms, but say, I mean, it's kind of. But
I'm just telling you,
anybody.
I'm the math teacher in this house in the school.
I know you're smart at math,
and so
man. You're smart at math.
I know about when I'm teaching my kids, all 33 of them, the different topics. So
yeah, I don't like exponents anyway, man. But look, so when you start talking about like for instance, man, to me everything works on equilibrium. Everything. I mean everything in nature.
So here's the deal. All you need to do then is provide an explanation then for when you set something on a scale, you can measure the downward force that is applying to it, right? So if you put it on a scale, you'll get
right.
Pounds or newtons, right? Newtons is the SI unit for force. You'll get newtons, and when you set this on here, and if it's a kilogram, and you set it on there, you'll get 9.8 meters per second squared because it's a kilogram, right? So
right, but shouldn't it be gaining in weight if it's accelerating? But it's hitting something. That's why I said mass is a force because it ain't accelerating no more. It's hitting the ground or it's hitting the scale. Shouldn't it keep accelerating? No, I'm just fucking with you. You ain't got to answer that. But I wanted to also bring up, and this is to me, man, I would say they could. It's kind of got me messed up, man, and in my own head a little bit because I feel like they could easily prove this because I got a globe here. Everything and like I got a couple videos of my grandkids playing with it. They love the globe and all that and stuff. Man, I'm not gonna teach them the Earth is flat. I'm not gonna teach them it's a globe. I'm gonna teach them to have an open mind and I'm gonna tell them what is. I'm gonna just teach them what is, right? And you know, when they get older, I might give them my opinion and everything. But getting to the point is like you look at the tip of South America, and then you look at over in Australia or New Zealand, it wouldn't be a long trip, man. And even if they couldn't do that, even if they couldn't do that, they could at least do this. Okay. So they can film and if people say, well, why would they do that for you? I guess obviously they wouldn't do that for me or this debate, but a lot of people are in this debate and if it just gets to the right ears, but they could go to, okay. So we take a crew in Australia, okay, and we send them to the closest base in Antarctica, right? Then we take a crew from South America and we send them to the nearest base in Antarctica, and we make sure we're heading south, even though there are some anomalies, all that, whatever south says on the compass, anti-north, okay, and we go to the base. Each one goes to their base, they film it. No big deal. Okay. And then we time the time it takes for them to get from one base to another. So it's not a bunch of lengthy flights, dangerous flights, it's just, and the people say it's cold up there. Temperatures reach negative 80 at about 40,000 feet regularly. So temperature, I think when it comes to planes, especially the faster they go, it's heat they're worried about, not cold. I guess
don't think so.
And from what I've heard,
not when they're going. Yeah, they have to go really fast before that matters. But keep going. This is fascinating.
Yeah, so we could prove it, man, without doing a big long trip over, because obviously if they hit on one longitude, but then you could argue that longitude is made for a globe. But look,
what would this prove?
Good. Okay, so here's the thing. So if they went from South America to that base, Australia to that base, and then they simply left at the same time and timed each other to where they crossed paths or to where one got to the other, because in my opinion, in the common sense, on a flat Earth, that should be a pretty long trip. I can make good debates and show you anomalies with distances and flight paths and all that, and I'm sure you could show me conflicting information. But to cut to the chase, they should be able to. It shouldn't be a very long trip because the full extent of Antarctica is not very long, and if you figure they're a little bit, it should be no longer than about a 4-hour flight to get from the closest Antarctica base and the closest South America base. I think they could do that. I think that's realistic.
I don't understand what you're trying to do. You're just going
because
straight
on a
south?
flat Earth it would take a hell of a long time. So they go from South America to the closest base. So just to resolve any arguments, they see how long they were going. So everybody has a good idea about where they're at, the direction and where they're at. So, I'm sure they go from South America, the tip of South America, to the Antarctica base all the time. So that's nothing new. And same thing in Australia. But if that would debunk a flat Earth, if it only took like what it should, like 3 or 4 hours to get from the Australia base to the South America base, that would just totally debunk a flat Earth. But in my opinion,
to go from, okay, you want a base in Antarctica due south of Australia and a base in Antarctica due south of South America, and then have them fly from one to south, I get it, but then fly from one to the other? Yeah, fly from one to the other. It doesn't necessarily have to be due south. It's just got to match up with the time. What if they were to just here? I'm just spitballing here. What if they were to do like a race around Antarctica on the water? Yeah. Okay. You did hear the guy who won second place last year doing his flat Earth interview, right? And how he's a flat earther with the anomalies, and they're not allowed to drop below the 60th parallel. That leaves a lot of area uncovered, right? I don't know what you're talking about, but there is an annual race where they race around Antarctica. Yeah, they're not allowed to go, but at least the 60th parallel. Well, there's one spot by South America where they do cheat it a little bit, but they're not. I don't know why they wouldn't. Antarctica. Why would they not be allowed to go south of 60 degrees? Look up the rules. Trust me, I've looked into all this stuff, man. And besides that, but don't even look into it. Just the rules of the race. Just look at the Taboo Conspiracy or either Globebusters. No, I'm talking. But I'm talking to you. What rule are you talking about? There's a path they got to take, right? Because they're going through a lot of nations and all that, a lot of different. So there's a path that they've got to take. And the guy who was interviewed on Globebusters, one of the professionals, he said he does that race every year and everything, and he's pretty thorough. I can't vouch for him 100%, but he described everything in full. He's either done it or studied the shit out of it. And he was saying, that there's one spot where they drop down beneath the 60th parallel. They're not supposed to. The 60th degree parallel right there by right there at the tip of South America. But there's a pre-plotted route though. Yeah, so it's a race, and they give them a route. Okay, here's the deal. It doesn't matter 60th parallel or not. None of that matters. What really matters is the distance, because if the typical flat Earth AE map is right, the distance is somewhere in the neighborhood of 60,000 miles. And if the globe is right, it's way less than that. It's not that much at the 60th parallel. It's not that much bigger. Trust me, I thought this was one too, but it's really not that much bigger. And the point is that guy said because of the distance that he's a flat earther because of that. Just saying. Yeah, I'm not buying it. Doesn't prove flat Earth either. Here's the deal. That's my opinion. 60th parallel, right? South. You got 60 south. How far is that from the North Pole? And granted that they probably about, what would you say? If we're going to just say using the regular map, then it's 12,000 from one side to the other. So it's probably about 9,000. I don't know. But hey, that is the lowest they go though. So they average out on about the 50th degree. Just a second. So let's go to the 55 to be fair. We'll all right, fine. We'll do 55. It doesn't really matter. Now, if you look at the Gleason map,
I'm just kidding.
The Gleason map on the Gleason map, it says 60 nautical miles between each line of latitude. On the Gleason map. That's the same for the globe. 60 nautical miles between each line of longitude.
Are you talking about that map that's flat and says scientifically accurate in every way?
Yeah.
I'm just kidding, dude. I'm listening.
Yeah. It says on the map it's a projection from the globe. So I agree. It is a projection from the globe and it's accurate. So anyway, that particular map, as well as, you know, all navigation, has 60 nautical miles between each line of latitude, right? So if you are at 55 degrees south, to get up to the equator is 55 degrees of latitude. And then to go the rest of the way to the North Pole is another, how many? From the equator to the from the equator to the North Pole, how many degrees is that?
It'd be freaking the rest. So you got 90, right? I mean, 90, why would you ask something like that?
I want to be sure that we're in agreement.
Like that?
I want to be sure we're in agreement. So that's 145 degrees total, right? So we know the distance because all we need to do is multiply 145 times 60, right?
I'm with you on all that, but hold on. Let's do this. Go ahead, finish.
That's
I'm going to say so
8,700 nautical miles from the North Pole to the 55 degree latitude south. Are you following there? Are we good with that?
Yeah, but let me ask you a quick question.
Oh no, we're gonna finish this one.
Go ahead.
All right, I'm gonna convert nautical miles. I'm gonna do it. We'll do it in miles because we're Americans. That is 10,011. It's like 10,012 miles.
Well, you could do nautical miles is further and makes everything equal out to about 69 miles instead of 60, though. Wouldn't you agree?
Yeah. I mean, you just multiply it by 69. So there we have 10,012 miles is the radius on flat Earth of the 55 degrees south. Okay. So now we know
I'm sorry. Say that again.
The radius, if we're going with the flat Earth map, we have a circle from. And at the 55 degrees south, the radius is 10,000 miles. Right? That's the distance from the North Pole, right?
Wait. Why would no? Yeah. That would be the radius on a flat Earth.
It's the radius of the circle of the 55 degree latitude.
2 pi.
Right. So,
okay.
So the circumference is pi d or 2 pi r. Right. So we have 10,000 times 2 is 20,000 times 62,000. Okay. 62,000 miles is the circumference of the 55 degree latitude south. And it's going to get more. If you go to 60 degrees south, it's going to be larger
ain't the Gleason's map equidistant? Ain't it equidistant, though? I mean, you're stretching it a little bit, man. It is big, okay?
It is.
But you're stretching it a little bit.
According to the Gleason map, equidistant is talking about the lines of longitude from the North Pole. It does not mean...
The longitude...
It does not mean like Rob Skiba and Globebusters think. It does not mean that that it's equidistant between lines of longitude. It's equidistant.
I understand that.
Right? Because if you go with Rob Skiba and Bob Nodell, who posted a video on this, and you say that the distance between each line of longitude is the same, then you get a cylinder. And they are cylindrical earthers then.
Well, there's fair because I've been told that when I get up to the North Pole, it's 69 degrees per mile, per degree, right? 69 miles per degree.
Between the lines of latitude.
Right. But so what happens if you're looking...
between lines of longitude.
Right. They don't say that, though, man. It's like, if you're looking west, they argue, because when I'm arguing a plane and how much it should be dipping down, they're saying, well,
all right, let's get back. Hold on.
Go ahead.
There is a reason why I brought this up. At the 55 degree latitude south, The distance around is 62,000 miles on flat Earth. The race around Antarctica doesn't have enough time in it for those boats to go 62,000 miles.
So what would the equator be on a flat Earth? If it's 60 miles per degree.
Let's stick with this topic. Let's finish this topic.
Yeah, but I want to double check this math. The equator on a flat Earth would be 60 times 90, right? Would be 5,400, right?
Okay. The radius, yeah.
So if the radius is to halfway is 5,400, I mean, what would make it? I'm doing something wrong. I gotta be. So the radius. What would be the? I don't feel like thinking, man. I've had a long day. But what's the 2 power? So all right. You want 3 times 10. Okay. So 10 times 54. All right. What would be the circumference at the equator?
According to flat Earth?
Giggles, yeah.
Well, it's 6,200 miles from the equator to the North Pole.
6,200. What? Ain't it 60 degrees per? 60 miles per degree. Wouldn't that be 5,400?
69 miles.
Let's do that. Let's do it with that. Give me the benefit.
69 times 90, 6,210.
Why 69?
69 miles per degree latitude.
On the Gleason's map, it's 60. Ain't it 60? Or is that just for the
60 nautical miles, which is 69 imperial miles, or 110 kilometers.
That would. Okay, but if you converted it, that would make it smaller. So if you said on a flat Earth, okay, they use nautical miles because it's not as far. MC McToon. Everybody calls you McToon, dude. I gotta call you MC. MC don't sound natural, bro. You gotta bear with me on that. But think about it, dude. So if they say, okay, it's a nautical mile, you're thinking backwards, bro. So how far did you go? I went 69 nautical miles. Okay, so when really you only went 60 miles, right? So they call it 69,
that's
and they
the
say
opposite.
a nautical. Yeah, but if a nautical mile is longer, right? A nautical mile is longer. Okay, so the reason they would even come up with a nautical mile is because it's 60 degrees. It's only 60 miles. So they got to come up with some shit and call it a nautical mile, right?
Oh, they came up with nautical miles before imperial miles.
Okay.
Here's how they defined the nautical mile. They said they figured out. They said let's just say that there's a 360 degrees in a circle. Let's just make that up, right? And then let's be crazy. From the North Pole all the way to the equator, to the South Pole, to the equator again, and back to the North Pole, that's 360 degrees. Let's just say that between each degree, 60. They picked it because it goes degrees, minutes, seconds. If you've ever done any angles using minutes and seconds, right? So how many angular minutes? How many angular minutes in a degree?
Is it 60?
60.
Or 360?
60. No, it's just 60. And how many angular seconds?
Did you say seconds? Yeah, it'd be. Wouldn't it be like? Let's see. It ain't 360. It's like 1,600 or some shit. Or
I'll ask it again.
It's a lot, dude. It's a lot.
No,
I forgot.
I'll ask it again.
Much.
How many degrees? How many minutes? How many angular
minutes? No. And then 360 seconds.
3,600 seconds in a degree.
Yeah, 3,600. That's right. That's right.
So there are in angles. There's 60.
Dude, are we only going to do trig, dude?
This isn't trig.
I know how all the shit works. You don't got to start at the beginning, bro.
This isn't trig. This is how they got nautical miles. I'm just saying how they got nautical miles. They just divided a degree into distance, and they called it 60 miles. Because they're using a celestial
dome, right?
It has nothing to do.
Celestial dome.
It has nothing to do with anything.
They
said, here's 45 degrees north. Here's 44 degrees north. Here's 43 degrees north. Every one of them has the same distance.
Wait. How did they come up with that in the first place?
Well, you can
if they're using the angles.
Yeah, you can measure the
in the
angle
minute.
to Polaris, for example, or the
Then
center
they
of
had to use
rotation.
a celestial dome, right? A celestial dome. Thank you. But that wasn't even a point of contention. That's just the way they did it.
It doesn't require that. You can just simply measure what's the angle to the center of rotation in the north, right? The north celestial pole. You measure your angle at each step. You go one degree,
it,
1 degree,
okay,
1 degree.
Let's
it's
measure
60
it,
nautical miles
it on the horizon. Let's measure it at 1 degree. Let's measure it at 1 degree where you can't even see it.
That would be
come on, man.
60 nautical miles north of the equator is where it would be.
You lose it at about what 5-6 degrees. You don't even see it, man. So you can't say they use that.
You see it, but it does get harder to see.
You're not willing to admit. Are you? Let me get this right. You're not willing to admit that they used a celestial dome and used the sun and the stars
I'm
to
just
map
saying, hey, look,
the Earth.
We're getting way off track. I was just explaining to you.
Yeah, you're right. We are.
How nautical miles were defined. I don't give a damn how they did it. I don't give a damn if there's a dome, if there's a sphere. This is just the reality of how they defined a nautical mile. 1 degree latitude, 60 nautical miles, all the way up and down. Okay, that's how they defined it. Okay, so
latitude, longitude is mapped out on what? On a sphere, right? You
of course, yes,
out...
because when they did this, they knew the Earth was a sphere. It makes sense. If the Earth were flat, they may have used a different system. But since it's not, they used this. So that you were asking what's the radius of the equator, but the real thing we were talking about was the distance that the Antarctic circumnavigation race takes. And if the Earth is flat, it is at least 62,000 miles. But in reality, it's much less than that. Why would they call
that an Antarctica race? You can't sail through ice. Why would they even call it that? And why would the guy who got second place last year become a flat earther because of the times and distance?
I don't care about that idiot. He's not on here right now. It's you and me, right? So maybe that guy could. Maybe I could contact him and see if I could talk to him. But you're here, not him. So the distance and here's the reason why I'm asking was because it was just last week. They did that race just last week. And it's not, obviously they're not going through ice. It's boats on water. Boats don't do ice really well. Right. They want to avoid it so they can keep going fast.
So it's not around Antarctica unless we're on a globe, right? Well, I guess it could be around Antarctica on a flat Earth.
It could be, and it would be 62,000 miles or more to go around it. Now, here's the deal. If anybody wants to be the winner of the race or do well in the race, you'd want to take the shortest path. If the Earth were flat, they wouldn't try to go at 60 degrees south or 55 degrees south. They would try to take a shortcut and pop up to 45 degrees south or 40 degrees south between Australia and South America or Africa, right? Where there's big stretches of water, because that would be a straighter path.
Come up.
They go farther south because that's the actual shorter path. But that really doesn't matter. The real point is
to dip down at South America. They got to dip down though.
Yeah, you can't go past. Yeah, because South America goes down to about 55 degrees south. Is the southern tip of
right. So there's no getting around
Argentina
it. But
yeah.
It is a good map, and I really have no argument against that, except to say that the guy who is in that race, supposedly to his claim, and it wasn't me, so I can't say it for sure, but he did come on talking about the anomalies and the speeds and all that shit. But I can't make that claim, so I'm going to have to concede this one.
Okay. Let me read some super chats here because I'm getting backed up and we're an hour in. So
good. Hey, I need a minute anyway, man. If you ask me, all right.
I'll save for you, I guess, if there's anything specific. Let's see. Oh, there's a bunch that came in. Alyssum says, if he's really open-minded, ask him why over 100,000 flights every day. They're not doing it right now, right? But rely on functional globe-based maps to navigate the world. That's great. Like these maps here. QTube for $5 says the flat earth evidence must be good. They've been using the same evidence for many years now. Yes, that is absolutely it. But he said he has a new one. We're looking forward to that. This will be the first new one I've had in a while. Conical Reason for 20 Canadian says measurements is the answer to all your flurf nonsense. Merry Christmas and happy revolution around the sun. Thank you, Conical Reason. Lael for $5 says Brian is correct. There are stupid arguments on both. Too bad on flat Earth 100% argue. Okay, Brian is correct. There are stupid arguments on both, and bad arguments on flat Earth 100%. I think is what he's saying. 100% of the arguments are for flat Earth are stupid. Sorry, the grammar was a little messy on that, but thank you for that, Lael. Conolix Silver Fur for $5 says, does Brian understand that one object hitting another results in an exchange of energy? And the object itself isn't energy. No, I think that is what he missed. So, and again, Conolix Silver Fur, I want to say like Silver Surfer, says density doesn't explain why objects fall to Earth and not any other direction. He did say it wants to go back where it came from, which doesn't work. So, Lael says for $5, Brian seems to think gravity is sentient and cares what things are. Yes, I love the one where they're like, it can hold all the tons of mass of the oceans of the Earth, but it can't hold a butterfly, like as if the butterfly has wings and it flaps. There's forces other than just gravity, people. You can have forces up. And Brainy Beaver, yeah, we like, just as you said this, like our topic flew off of this, but for 2 Canadian says my micron gauge measures molecules for vacuum sensors. Yes.
I'm back, man. I'm back. I heard a little bit of that, man. But yeah, there are dumb arguments on each side. I would never say about holding down the waters, but if you think about it, the waters are supposed to be, they're individual molecules when they need to be. Their gravity's acting on water when it needs to be, but you got millions of pounds of clouds in the sky. So that's a little bit better of an argument with that. But yeah, I wouldn't let the butterfly flap in the air.
There are more forces. There are more forces at play.
What's a force, though? I mean, that's point of contention already. What's energy? Energy is you transfer energy. So what are we transferring? It's debatable.
It's actually not.
Energy is an actual thing. It's a description, right?
It's not. It's not a debate. I mean, this is stuff.
Well, math is a description, right?
Math, yes, yeah.
Yeah. So energy, we use math for energy. So it's just a way of describing shit. It works for me, bro.
Somebody's asking, what's in the jar? Is it moonshine? This is not moonshine. It is, in fact, actually. I stopped drinking pop a long time ago. But every once in a while, I'll get some Zevia, which is, it's not showing up very well. It's pop sweetened with stevia, not an artificial sweetener. So I rather like it. It's just water.
A pseudo sweetener.
No, that's just water in here.
I'm just joking, dude.
Don't tell Red Pill Philosophy because he gets scared. Yeah, force is mass time acceleration. Energy is mass. Mass times velocity squared, mv squared.
Right, it's energy. A description. That's what I said. It's a description. It's math, right?
Yeah,
I'm good with that. I'm good with that.
It works. So now, Brainy Beaver was saying his micron gauge measures molecules for vacuum sensors. So Brainy Beaver has a gauge because he works with air conditioning and stuff that can measure the difference between the ground and the top of the ceiling of a room, or a room with a strong vacuum pulled in it, and then you release a little bit of air in it. He has a sensor. There are sensors that can measure the difference in pressure from the bottom to the top of that room.
Yeah. Yeah, and
So
contain it completely.
Brian Peck's wondering what channel this sailor was on. I think you said it was Globebusters, right?
Yeah, it was Globebusters. It was about 2.5 months ago, man.
Okay.
It was. I'm not sold on the fact that I don't think he proved the flat Earth. He made a good argument,
I
and
agree.
he kind of nullified, but I don't think he proved the flat Earth. I don't think nobody's proven either. That's why I think it's a great debate. I hate it when people say the flat earthers are stupid or stupid argument. That's why I see that at the beginning to make sure you didn't think that it was a stupid argument. I mean, it's a fun debate, man. It's a good debate.
Well,
It's
some people
debate, right?
some people won't debate because it's the same thing the people bring up, and there is such thing as an established fact, right? You can, in science, there are things that are facts, and generally the Earth's shape is a fact, but that's fine. We call it a debate for fun.
No.
So Alyssa,
the Earth's shape is not a fact, man. I've been surveying since I was like about 20, 21 years old. Probably about. Honestly, I've been surveying for about 30 years.
Do you have a theodolite?
Man, dude, I just my freaking auto level just got stolen, man, and I'm pissed off. I got to go get a new one, but that gives me an excuse to get a theodolite. But if you're talking about using long distance theodolite, spare yourself, because I'm not going to do a discussion on optics.
Let me. We got Alyssum said he's trying his hardest. Be nice, Tune, and then it's something about Dyson's law as it deals with vacuums. So.
Yeah, okay, but so would he say that if we took the best vacuum ever pulled on Earth and we add like just a little smidge of air, is it going to sit on the ground? Let's be honest, man. Look, I've already conceded a couple things, man. Let's keep this fucking honest now. Excuse my language. But look, would it sit on the ground? Would it go toward the bottom? No, it would be equal pressure
because it's
toward
not equal. It would definitely not be equal. It would be higher pressure near the ground, lower pressure near the ceiling.
It would be contained, right? It would be contained.
Yeah, because there's a physical container.
So if you put a helium balloon in a vacuum chamber, it's going to have equal pressure around that balloon.
Not
would you
actually.
Concede that at least?
No, not actually.
Really?
Because
okay, all right.
Because
all right,
as I said, the pressure near the ground is higher than the pressure at the top, right? So a balloon is in the chamber where there is a pressure gradient. Lower towards the ground has higher pressure, and then less pressure as you go up. So the bottom of the balloon has less or more air pressure than the top of the balloon. It doesn't matter if you're in a vacuum chamber or in the regular atmosphere. It's the same. Got it? He's still there? He went silent again. Oh, connecting to audio and can't hear. Oh, man. Kind of like Silver Fur says, math is the kryptonite of all surfers. That's why they run from it. There's one I know of that can math, and that's Mind of God. But he thinks that it all presents as a globe and that God is just confusing us or lying to us. That it's actually flat, even though it looks like a globe. So I don't know. But yeah, I've not seen, just solve a triangle. Can't generally solve a triangle. So, all right. Cretan Ball for 5 Canadian says, I'm sure Brian studied calculus, but the extra equations made him suspicious. Thanks for at least being a decent guy so far. Spike Smith for $2 says, what's Brian's education / professional qualification? That's a great question. I will have to ask him. And I am not getting very far on this yet. Just, this is probably the least I've had. So he did say dome, didn't he? He did say dome. Yeah, low pressure, high pressure systems next to each other. Bad math.
Hey man, sorry about that. That was great timing on.
Okay. Oh yeah, new name for gravity. We got that.
Can you hear me?
All right.
Can you hear me?
Mute Donkey. He knows 2 + 2. Are you back yet, Brian? It looks like you're back. I don't hear you though. Can't they just cut out the middleman and use QF27? Yeah, QF27. It's my favorite. I love the number 27 too because of Weird Al. So it is. It's the number that I remember the most. Sydney to Santiago goes south of New Zealand. And Alyssa for $2 says, does he really want to trust 15 degrees per hour drift, Bob? Thanks, Bob. Yeah. Bob was, I think I said this last week. Bob was commenting on a video I was commenting on about some guy that I was trying to find somebody to debate. And Bob was commenting and he was trying to dig on me. And I just returned him back. I'm like, hey, how come you don't debate? What's going on? Challenge you to debate and you don't come. And then I said it in a second comment. I said, where are my manners? Thanks, Bob. And then I got blocked from that channel. So,
hey, can you hear me, McToon?
What would the equator be on a flat Earth? Unnecessary. It would. Yeah. Like you'd focus on the maybe, I don't know, you'd focus on the Tropic of Cancer and Tropic of Capricorn, but the equator might not matter as much. Stringer News 1 for $2 says, do they dip their noses because reasons?
He's acting like he don't hear me.
Brian, are you talking? It looks like you're even talking and I'm not hearing you. Could be my fault. Let me see. Oh, it is my fault.
Buddy.
My headset dropped out. Yeah.
Yeah.
Hold on. I'm reconnected.
Hey,
there we go. I can hear you now. I can hear you now, Brian.
Like 3 times. All right, I've been listening, but I don't have the YouTube feed, but I can hear you.
Okay, all right. Did you hear me ask what would be the equator on a flat Earth? Unnecessary.
Yeah, unnecessary. But hey, why don't we have a globe, a sun and moon globe clock? Oh, that's right. It doesn't work. Just a flat Earth sun and moon zodiac clock app. Go to that, and wherever the sun is, it just happens to line up with where you're at on Earth. What a coincidence! But
none of it's right though. It doesn't predict anything accurately. But let's get this. Somebody was asking. Spike Smith was asking.
You can say that. You can make that claim and then just move on.
Yeah, I can show. I'll come back to that, but I want to ask this one because before I forget it. Spike Smith is asking, what's your education or professional qualifications?
I own a business, man, in Florida, concrete business. Been dealing with flat level my whole life. That's it.
Okay. So, all right. So here's where the AE map completely fails. Yesterday was the solstice, and in Sydney, Australia, the sun rose south of due east and set south of due west. But
I can't believe you're bringing up that from last night, dude. Have you seen the different? Have you seen all the live stream comparisons of where the planets were? It didn't line up on a globe, bud.
I wasn't talking about planets. I was talking about sunrise and sunset.
Okay. I got an explanation for that, but go ahead.
So the sun rose south of due east and set south of due west, according to the AE map, the only flat Earth map that really people kind of agree with. The sun would have been
according to the Earth's magnetic field, right? According to the Earth's magnetic field.
Wait, I wasn't done. According to that map, the sun must rise somewhere around 45 degrees north of due east. It's in the neighborhood of 81 degrees off. 81 degrees. A very, very big error. On a globe, if you in fact use a globe and set up this,
I've already done it. I've got a video on this, Victor. Let me cut in real quick.
No, no,
Okay,
I'm
so
almost done. I'm almost done. I'm almost done.
Okay, good.
And you set it up so you have it here. Let's see, right here like this. So this would represent, if the sun's over here, this would represent the December 21st solstice. And you look at here's Australia, and you look at the angle to where the sun would be. It matches the globe here. I measured it myself.
It most certainly does not. Okay, so what I did, let me cut in. So what I did is I took a little laser pointer, okay, and a spotlight. So the spotlight is the sun, and it's lined up with the center of the laser pointer. Okay, I lined up the laser pointer with the center of the what you call it, oh my God, the analemma, right? So the center of the analemma, you line up your laser pointer, and then you center out your spotlight, because that's what the sun does. That's what we see in high sky when there's not much refraction. Anyway, I got a video on this on my channel. It's pretty short.
No, I said from Australia, not from the analemma, which is just in the middle of the ocean.
No. So I lined the laser pointer up. Let me finish. I lined the laser pointer up for the analemma. I center my spotlight out, okay?
Why are you talking about the analemma?
Because that's how I lined up my light according to the sun.
Why would you do that? That's the light we're
using, right? Why are you getting rude on me, bro? Honestly, I mean, have I been a dick or something?
You're not making sense. I explained, but you wouldn't let me finish my explanation for what I was doing. And you wanted to just jump in and. But
I waited for you to finish and apologize. Go ahead, refinish, McToon. I'm sorry.
And I set it up. I put on one side of the table. I put a light, the sun, and I put then the globe on the other side, and I used a toothpick and some Play-Doh to point right to the sun, so right there was no shadow on the toothpick. And then I measured that angle.
I did the same thing,
right?
Bro. I did the same thing, and I got the results you're talking about. But listen, if you use a sun, if you simulate a sun and use a laser pointer and line it up with the center of the analemma, and it lines up with the equator, just right by the equator, you spin the globe, it matches up perfect. It's an actual simulated sun. And you start spinning that globe, the light does not come in from the south. It works with the toothpicks and the shadows. It does not work with the simulated sun. Go to my channel, look at Australian sunrise, easy debunk. There's plenty of problems with the globe, bro. I wouldn't be here if there wasn't.
I have no idea what you're talking about, because it worked
obviously
perfectly.
Yeah, like I said, the toothpicks and shadows, you could get that to work, okay? But if you simulate the sun, once again, this is why I use the sun, because that's the light that shines on the earth, right? So once again, I'll make it quick. I used a laser pointer and lined it up with the center of the analemma, right? And then I used a spotlight and line that up with the center of the laser. So simulated the sun. I backed the spotlight up. So when you spin the globe, it's just like we see, right? And the light does not come in from the south, okay? The best I could get was dead east, okay? It does, on a globe, if you simulate the sun with a laser and a spotlight, line it up with analemma, the sun does not come from the south.
Why is there a laser and a spotlight?
Because the laser, to make sure it's dead accurate. You could try and center a spotlight with a tape measure and a fucking plumb bob, but to make sure it's accurate, they got these little lasers. They're like $60, and it tells you the degrees. And they're pretty cheap. They're like pointers, and you zero out the degrees, and then you line your spotlight up according to the laser, because you don't want to just throw the spotlight right up on the globe. You know, you're just trying to simulate the sun accurately, and the only accurate way to do it is what we see in nature, and that's the analemma. So the center of that analemma is where I'm assuming the sun is, which leads me to a question: why anywhere on the globe we get a bigger loop for the southern analemma? That's a question that just popped up.
It has to do with the orbit of the Earth. The orbit is elliptical, not spherical.
Okay. And now, anyway, you can do this yourself, or you could just watch my video, because I do it all.
I have it
there in real time.
On the screen right now. Everybody is seeing it. 330 people are seeing my prediction, where I have some Play-Doh. And I pointed it towards the sun on the December solstice, and I got 27.5 degrees from Eastern Australia.
Well, you should play my video real quick. It's called Australian Sunrise. It's on Flat Earth Test channel. It's short, but you don't got to. But I'm just saying, I can't see it either way.
Yeah. All right. Of course, the prediction for flat Earth was.
I don't know what the circumstances may be, and I'm not quite sure if it works on rear wheel.
I'm in a live debate, bro. Give me a minute.
Okay.
The predicted sunrise on flat Earth is 53 degrees northeast, so instead of 27 degrees southeast. So, all right.
It doesn't work on either. I've already looked into this, but that's my opinion, and that's what I came up with.
What was it?
A simulation.
What was it called?
Australian Sunrise.
All right. 4 months ago. All right, let me grab this. 2-minute video. All right, do we need audio?
Analema. They say that the flat Earth, sun, moon, and zodiac clock, or a flat Earth AE map, doesn't work because the summer sun in Australia comes in from the south. Okay, so this is the model, and also time and date shows the sun coming in from the south. So,
all right, to start off with, you have it set up.
We know the sun comes in from the south because I agree with time and date.
Okay. All right.
it is accurate with reality, but let's see if it's accurate with a globe. Okay, so here's the analema. There's a laser and a hot spot to show you that I have the sun accurate. This is what we see in the skies. The season goes on.
Wait, why are you moving?
The season goes on. Here is the.
Oh, you're moving the
hemispheres.
seasons. Okay.
And I got a laser on.
I'm just showing you that it works out at a full rotation. It works perfect.
Okay, there's the laser right there. Okay, so there, show you that it's accurate. Now I'm going back to the southern hemisphere summer. Okay, to show you that it's okay. You don't have that. So now we're gonna, so with it accurate in the sky, here comes sunrise for Australia. Okay, so we're coming around, and there's where it's sun's starting to come up in Australia. Here's the terminator line. So the sun's peeking in. Here's Australia, and it is not to the south. Okay, I repeat, the sun is.
Hold on a second. You said it's not to the south.
Yeah, I know. Dude, I need to get you to go to my other channel because I have the degree thing. I didn't show you the close up. God dang it! I forgot all about that. I wouldn't even had you pull that up. But no, it's not, man. It's the best in North Australia. Look, in North Australia, it's like
here's
pushing 1 degree south, bro.
Here's what you do. We can't even see Australia here, right? What you want to do is you want to get Australia, go to Australia on the globe there, and as a person standing in Australia, point to the sun. It's south.
It's not to the south.
Look at the way the light's coming in. It's not coming in from the south, bro. Look at the way.
We don't even see Australia here.
You know it's coming in. No, you know it's coming in from down there,
it's
right?
coming in. It's coming in from the south. I don't know why you're even saying that it's not coming in from the south, where it's pretty obvious it's coming in from the south.
When I get back to the house, I might set it up, man, to show you the degrees on the pointer. But yeah, man, it wasn't
of Australia. Say right here, you could almost say.
So what you're doing is you're wondering if Australia. Oh my gosh! Why? You're looking at the analema. You're not looking at what Australia is experiencing. You're looking at the analema. That doesn't make any sense at all.
No, I used the analema just to spin the globe around to show that it lines up with the equator.
Oh my gosh! Yeah. But what is as a person in Australia experiencing? You can't even see from here.
from
Maybe
just east, not north.
They're experiencing exactly what they say, I believe. I believe they're
And the rest of
experiencing exactly
Australia-
what they say, right?
I mean, it's east at best. It's not south in no way, shape, or form. So neither model.
You just said that it's not south, and it definitely is south. I mean, that's exactly what.
But not on a globe, McToon. I mean, at least understand the argument, bro. Why are you being like that, dude? Look, I'm not saying that in reality it doesn't happen like that. I'm saying it doesn't work on the globe or the flat Earth. That's my claim.
Here's the thing. I have on mine. You can see the Terminator line. You can see Australia in my example, and then you can see the stick that I put into the Play-Doh pointing right towards the sun. So that would show what somebody who's standing in Australia would see, and it gives us the angle.
Well, you should try my test.
That.
You should. It's not that hard. Just
I have it on the screen.
Get a pointer and a spotlight.
I have it on the screen right now. I used a spotlight.
Did you circle your globe to show that it's lining up perfect?
Circle the
Because
globe.
if you're not coming in at the right, listen. If you don't line it up right, it's not going to work. Complete rotation of the globe. You got to show a complete rotation of the globe if you're going to do it accurately.
Yeah, I measured the elevation of the center of my light, and matched the center of the light elevation with the pivot on the globe there, so that it's they're at the same height.
Okay, just stick, show that with a laser, do a full rotation.
Yeah, the thing is, here's the deal. Your analemma thing just shows that you're not understanding why the analemma is there. The analemma is about not just the rotation, but also about
So now I don't understand the globe model even. So
yes, that's correct.
That's how you think of me, bro? Okay.
So
right,
because and I know that because you rotated and you tried to compare the analemma. But the analemma, the reason why the analemma is a different size on the top and bottom is because of the orbit. And your demonstration where you're testing it before didn't simulate the difference in distance of the orbit. So you force the analemma to fit the laser pointer unnecessarily.
And it just coincidentally worked with a full rotation of the globe, keeping the laser on the equator, dipshit. Are you kidding me? I'm sorry, the analemma you couldn't properly demonstrate the analemma in the way you set it up because you weren't properly demonstrating the difference in the orbit. Analemma. I lined up with the center of the analemma to mock the sun, and I put a spotlight.
Don't line it up with the center of the analemma. Line it up with the center of the Earth. I'm
not going to be biased toward your explanation.
If you're doing it wrong, right? If you're representing the globe model wrong, then I don't care. You're debunking the wrong thing. You're debunking the not globe model.
On the equinox, the sun is in the center of the analemma. I don't care what shape it's doing.
No, it's not.
During the equinox, oh my god, dude. During the freaking equinox, man. It's right in the center of the analemma, man.
The center?
It's equal day, equal night.
Yeah, it's on the equator. It's on the equator, not on the center of the analemma.
The equinox, dude, really?
Oh my gosh.
Okay. Then what good is the equinox? What good is the analemma for a globe proof?
It has to do with the orbit and the distance that the Earth is from the sun, and it varies in its orbit. It's an elliptical orbit. This has to do with Kepler's laws and stuff like that. We don't need to look at that.
About reality, bro. Listen,
I know, and we don't need to look at that when we're examining this.
Bro, please get with reality. I understand your argument and my argument. Now get with reality. What the analemma is, I don't care what the Earth is doing, what's flat globe. In reality, listen, the sun is in a certain spot every day at noon, okay? Don't worry about your model or my model. The sun's in a certain spot every day. You with me, McSoon? Okay? Now, if you take a picture of it every day, I'm not talking about models. Dude, you're not thinking neutrally. I'm trying to think neutrally with you, man, and you're not thinking neutrally. What I'm saying is what we see in real life, okay? And what we see in real life is the sun in a particular spot. I don't care what your model says, okay? I'm talking about what the sun says on equinox. Are you with me? Sorry to get loud, bro, but you're acting stupid, dude. Like you don't understand what an analemma is. I'm not asking for the description of the analemma on your model. I'm asking for what we see in reality.
Yeah, but
no
here's the deal.
Shape.
If you're gonna test,
do you understand me now, Lou?
No, if you're
just
gonna
tell me you understand me, please.
No, you don't. Here's the deal. If you're gonna test
So
whether
you
or not,
can't even think neutrally.
No. Here's the deal. If you're gonna test
You
the
can't
angle,
even think with a neutral mind. Is that what you're telling me?
Listen up. If you're gonna test
all right,
the sunrise angle on the equinox or the solstice, you need to properly represent the model. And your analemma thing, by force matching the analemma to match, that showed that you did not understand the model.
I'm going with reality and testing your globe.
No,
okay?
you are misrepresenting the globe.
They can put an analemma that they drove from reality and not line it up, okay, and give me an excuse for that, but I'm still going to go with reality. I'm just trying to get you to think neutral, what we see in reality, then apply it to a model. Don't misalign it and say this and that and give me an excuse, right?
And so ignore the analemma because that has nothing to do with this particular test.
All right, I'll calm down too, man. But God dang, dude, I'm trying to get you to think, we're supposed to be looking at boat models and shit, man.
Yeah, exactly. So all you need to do then is provide the test that is the actual test for the model. And I have it on the screen right now.
Bro, you can show me the equator all you want, but in real life, okay, the sun on equinox is right there in the center of the analemma, bro. Why can't you at least understand that? You don't have to agree with it, bro, but you don't even fucking understand.
The sun,
are you kidding me?
On the equinox is over the equator.
Yeah. Where is it at? Okay, it's over your equator. Then why is it the center of the analemma?
The equator is not the center of the analemma. Or do you mean the cross point or the center? It's vertically centered if you use that, but so ignore the analemma when you're doing this particular test. It has no bearing on it.
Bro, why do you think they don't put the analemma near shore? Okay, that's the point of contention, McToon, is what I'm saying. Let me calm down.
They don't put it near shore because they don't want to put it over land because it's meant to be a map. And if you put the analemma, which is just a drawing on top of it, over land, then you don't get to use that land. So they put it over water where there's no, maybe there's some islands there that they wind up covering. But in general, it's in the south. It's in the Pacific there where there's not a lot of islands.
Okay, but anyway, let me give you my explanation for the possible explanation for a sunset. And I had one other point. Here's a fair explanation as far as the throw a light on the AE map. I'm not saying it's 100% sure, but it's a fair argument at least. Please try and open up your mind a little bit. It's fun. At least it's funner if you open up your mind. To me, it is. But so you have the layer. On the beginning of that video, it showed the explanation of why we see the Josh Nowicki photo, why we see the Chicago skyline, blah, 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 blah.
Yeah, because the refraction raises distant objects.
Yeah, it's because the cold air over Lake Michigan. So what we did is, I'm sure you visited Rancy's channel here and there. And the guy, shout out to Peter the Great, or Pebble in the Pond. He came on recently, and he's done a bunch of different scenarios of being, and it is a little bit extreme as far as temperature goes, but he's in a warehouse, and I think he's about 100 meters or a couple hundred feet. That's not real important. The point is it's like near freezing outside. It's about 32, 33 Fahrenheit, 70 degrees inside. What he does is he sets up a light on the ground and his phone on the ground. We've all seen versions of this, but he did a good one, man. He when it's cold outside, he opens up the warehouse door, right? And he's got 3 lights set up at different heights, one at like 1 inch, one at like 2 inches, and one at like 4 inches. And what happens every time, he's done it from different spots, like kind of simulating the sun coming in from behind. And he's done it, but they're getting to the point. Every single time he's done it, and he lets in the cold air, and then he shuts the door. And it doesn't take but a second, and then the bottom light disappears.
Keep going.
Yeah, the bottom light disappears, right? Yeah, the bottom light disappears, man. And then the next to the bottom light disappears. And I told him to do it with a laser to see what happens. And hopefully that message will get to him. Actually, I left a message. But And so in my opinion, I think it's fair to say that, hey, when you got cold air coming in under hot air, you lose shit from the bottom. I mean, I've seen it with my own two eyes several times. It's at least a possibility. Whether it happens or not, you know, every time, at least so far, every time I've seen it, it's a possibility. So what you have, and so would you agree with the claim that when the light, I mean, it's science that light bends toward the denser medium. We know that. Okay, yep. We're not arguing that. But would you say that so it's denser on the ground, like the black swan explanation would be it's denser toward the ground and the light bends down, making objects appear higher?
Yeah.
Would you agree with that?
Yeah, that's measured.
Okay. So, you know, and we have in our atmosphere, we have a spot, man. And that was my video. I was getting kind of fun with the focal point thing, but I was serious about the fact that it gets colder, and right about 40,000 feet average, it changes, but it gets, you know, a maximum of 80. I think they have it listed in, on Google page I looked up as negative 70 Fahrenheit. And
okay.
Then there's a layer, and when it gets up, and you can cross-reference this with the balloon launches and the data. But every one of them, it gets super cold. It starts getting warm, right?
It starts to warm up again. Yep.
They also say that temperature doesn't play as big a role as pressure does in refraction.
Pressure is a bigger. Pressure is much larger.
Right, but temperature, you know, does play a little role. Blue taught me about that. Blue Marble Science.
Yep.
He taught me about that. It's just a small percentage, but I'd say this. So this is a possibility. So. And because you don't have hardly any pressure up there, and the pressure goes up a smidge, so that would follow the argument I have, but it's not a lot, but it does go back up a smidge. But the pressure's so low, it doesn't. I don't think it's much of a factor anyway. And but the temperature it's a swing of up to 110 degrees. Probably averages about between 90 and 100 degree temperature swing. There's no water vapor up there to speak of. There's no pressure up there to speak of, and you have a hell of a temperature swing. So you got a spot that's about 10 miles long. It's about probably 50,000 feet, or somewhere between 30 50,000 feet of an area in our atmosphere that goes from cold to warm. So that would mean without the temperature and all that. My point is that with the moisture down low, I mean, with the moisture non-existent, you know, that it could bend the light upward, you know, toward the warmer air.
It could. So when you did this modeling, did you use the Cauchy equations or the Sellmeyer? You couldn't use a Sellmeyer?
My own way, bro.
I mean, you could have used the modified Edlin.
Information, bro.
What's conflict? You don't like the Edlin equation?
You don't like ideas,
I would use math. I would totally use math, because here's the deal. In order for this to work, you are suggesting that it's actually
I'm not
a
gradient. Bro. I ask you to open up your mind.
Okay. So here's the deal. So then I'll explain what is understood about refraction. It's
if I wanted to hear your explanation, I'd just read Wikipedia, bro. What are you talking about?
Well, maybe you should have done that. If you would have done that, I thought you'd finished.
It's killing you, wasn't it? It's killing you, giving you an idea. Just a simple idea was killing you, wasn't it, to hear me?
But you didn't.
Was it killing you, McDude?
It was very unrigorous is the problem. But continue with your unrigorous idea. Go ahead.
Well, anyway, but here's the thing. Okay, so I've seen a lot of conflicting information, different equations, not just one. There's different ways to figure shit out. They give you different heights where the vapor stops. There's contentious information you will get when you research a subject, okay? So I just come up with my own idea. It would have to, if the Earth was a plane, the sun would have to disappear. You can explain how it would go down, you know, but if the sun is 10 or 20,000 feet up in the air, it would have to, that could explain it getting lower, but in my opinion, it wouldn't explain it disappearing. So I just had the idea that layer over long distances would bend the light up, making the sun appear down. And if the sun has a limited throw of light, and they also, on a side note, they bragged that the ultra low temperatures is they've slowed light down to 10 meters a second, and that's what mainstream's bragging on now. So the Arctic is not an extreme low, but it's a very long distance of low temperature. So that way, the last thing that would explain the throw of light on the 80 map, how they say it should equal out and throw over the North Pole, and it doesn't. Well, all that cold air and obviously slows down light. They've proven that, so that could affect the throw of the sun's light on a plane. It's possible. I'll say that. All right, go ahead.
All right. Well, first of all, the when they slowed down light, it wasn't in air; it was in a physical medium, and temperature is certainly a deal. But within air, people have
it was in air
where they slowed down light to 10 meters per second.
Unless you want to admit it's superfluid, McToon.
They did not slow down light in air to 10 meters per second. It was in a solid, maybe a liquid. I'm not sure, but it was not just in air.
Unless you want to admit it's superfluid, McToon, they slowed it down in what they define as helium-4, right? Would you call that air?
That's liquid.
It's superfluid at that stage. But anyway, go ahead.
So, yeah, and we don't have helium-4 in superfluid over the Arctic, so that doesn't do much. So, but here's the deal. We have...
I agree with that.
people have figured out, and that's why I was asking if you prefer the Cauchy equation or the Sellmeier equation or the Sider equation, or the one that's most commonly used is the modified Edlin equation. Even the FE core garbage thing that measured road curve over Lake Balaton.
Why would they need so many equations if you don't mind me asking?
Because over time they've understood it better and added more things. So like the problem with
the previous math was wrong.
No, it's called an improvement, right? You do concrete, right?
That's a kind way of putting it. Okay.
And when you first started out, I'm sure the tools you were using then aren't as good as the tools you're using now. And maybe there's a tool that's like some really nice high-end tool. You're like, I can't justify buying that for my business, but it sure would be nice to have that tool. It's a better tool. Right? So these things improve over time. So when Cauchy defined it, Cauchy's equation is only good for certain materials. Sellmeier had a better equation, and you could use it in more materials. The modified Edlin equation is the one that's most heavily used now. And like I was saying, that's the one that the fake Dr. John D used in the FE core Lake Balaton thing where he misapplied it. But that's a different story. Anyway, the point is that it is a pressure gradient, but it's more pedantically described as an index of refraction gradient. And pressure is the biggest factor in that. Carbon dioxide and humidity and temperature. Temperature is number 2, and then carbon dioxide and humidity are very, very small. And in fact, humidity has the opposite effect of what most people think it does. So you can use these things, and you can know that.
Wait, does it have more than them? Wait. Does it have more than them equations think it does?
These equations are very accurate.
Wait, you just said that the humidity plays more than people think it does.
No, it goes the opposite direction. It goes it pushes the index of refraction the opposite direction of what most flat earthers.
Like a cloud rising in the sky. I hear you, McToon. God, you don't even like that. God, no, you must think real low of me, bro.
I'm talking about the index of refraction. I'm not talking about clouds.
Well, you just put me in the category of most people. Like most people think, dude, yeah, if water floats up into the sky, obviously it's less dense. I mean, dude,
no, I'm not talking about the density of water. I'm talking about the index of refraction of air when there's humidity in the air.
Right. I was just giving you a real life example. Like air is less dense. People might think it's more dense because it's water. No, it's less dense. Like a cloud rises up in the sky. It's less dense, right? Sorry, man. I just get... God. Anyway, Rumpus game. I'm blaming this on Rumpus, man. He's got me like this, man. But I could never have a debater really learn anything. Like you taught me about the calculus earlier. I could never learn that from Rumpus because he's so freaking condescending, man.
Rumpus's only thing was velocity equals acceleration times time. That was his only thing. So, all right, let me get to the point of this is, you're right. The temperature goes down to a certain amount, and then the temperature starts rising. But the pressure being the biggest thing, by far, the biggest impact of the index of refraction in air is temperature. Or sorry, is pressure.
I can hear the plain truth in my ear. Can you demonstrate that refraction through that zone? Has it ever been demonstrated?
Yeah. I don't give a damn about about Travis.
Well, we like to see in the flat Earth. We like to see demonstrations, man, and we ain't getting many lately. Go ahead.
Index of refraction has been measured. So to conjure up some idea of here, you have to, I'm not going to accept it unless you demonstrate in this particular way.
You mean 7/6R, right?
That's not what I'm talking about at all. I'm talking about index of refraction, not coefficient of refraction.
I thought you said standard. Yeah, that's standard refraction 7/6R. You know, I mean, I'm not even going to go that route, but
yes,
you know, that's not legit when you got R to find R. That's kind of crazy, right? Because what they go by with refraction.
Let's not get off that. Let's not get off track. Hold on. Let's get back to. We're talking. You hypothesized. It was a fine hypothesis about the temperature reducing as you go higher reducing up to a point and then starting to climb again as you get higher in altitude. And that might cause...
But we're losing humidity too, though. We're losing humidity.
Like I said...
So that was the key point.
Like I said, yeah, the thing is, humidity has a very small impact on the index of refraction. First is pressure. And here's the deal. At ground level, the index of refraction is 1.00029.
Wait. Did you just say humidity has no impact on refraction?
I said it has very little. I said has very little.
Okay.
Humidity is.
I object.
Humidity is water, not droplets. Humidity is water dissolved in air. Okay, it's not droplets. So droplets of water in air are clouds. We call them clouds.
Oh my God! I'm gonna hold it in this time.
So here's the deal. These we know what happens. So you get up to that particular pressure, and you're 0.1% of the pressure at ground level when this temperature change starts to happen, or somewhere, I don't know the exact pressure amount. And so the index of refraction has gone from 1.00029 to 1.000 and many more zeros before you get to a number. It has already gone down, and then changing the temperature at that amount has such a nominal difference in it that it's not going to do what you want, what you think it might do.
Are you done reading that, McToon? Anyway, I've read the same thing. Okay, now look, I'm not saying
reading.
Is that
I'm not reading anything.
Demonstrated it. Listen, they've never demonstrated that over long distances. If the Earth is a plane, okay, there has to be a mechanism on how the sun, okay, and I would have to come up with something that they haven't demonstrated yet, and that's one idea of how the sun could disappear, because in that layer there is conflicting information, and you would have to agree that as you go higher, the humidity goes down. So if the humidity goes down, the higher up you go, the less humid it is. And I'm not saying it plays a bigger role in refraction, but over 6,000 to 8,000 miles, it could play a possible role. It's just an idea. You don't got to get upset with it. It's just a possibility on how the sun could work, and also explain the uneven light over the North Pole. I'm just giving an idea, man. What I led with it was just an idea, bro. You're not supposed to get all mad and contentious about that. But I did have one more thing. Right?
Okay.
Is that I was just giving a possibility. That's all on that one. But one more thing. So I was looking up yesterday. I wish I could send video, but it said how, so I picked a constellation. Okay. Now, the argument is, and I'm sure you heard it before, that if on the equinox, let's say, just who cares? Let's just say, okay, it's June, okay, and the sun is over my head at noon. I'm in Ecuador, okay? Let's just say I'm in Ecuador.
It's a
I
good
want to
song.
pick a constellation we could see. Yeah, right. I want to see.
Have you heard that song? It's a great song.
I want to pick a constellation we could see from the northern and southern hemisphere. Okay, so at night we're going to see. You know, I'm just picking one we see from the northern and southern hemisphere, and Orion happens to be one of them. Okay, so if the sun is over my head at noon, and at night Orion is up there, not at the north or south rotation. So now, 6 months later, let's say in December, okay, December 21st, I'm opposite the sun. According to both models, whatever, or according to the heliocentric model, I'm opposite the sun. So at noon, I'm looking the exact opposite way, okay? So to me, there should be months. So when I looked it up, it said there should be months where I should see a whole new set of stars. I shouldn't see them same stars, maybe a couple off to the north and south on a globe. But I should see a whole new set of stars up above me, right? There shouldn't be none of the old stars nowhere on Earth. So if they've moved around a little bit, I'll give you that, okay? But nowhere on Earth, okay? Everywhere on Earth should be a brand new set of stars, okay? And that's the one I can't get past as far as the globe goes, because I looked it up and it said, you know, Orion's best seen during the autumn and winter months, and then it said that it's gone for 6 months. And then I looked up and found a teacher giving a teaching thing and showing freaking June 21st, freaking in America, showing Orion and talking and doing a whole lecture on Orion in June, and that's not autumn and winter. So to me, it just doesn't quite work out. Have you
seen Orion? Have you seen Orion in June?
Well, let me send you this video real quick.
So here's the deal: the Big Dipper in the northern hemisphere we see year round, and that's predicted on the globe. But we don't see Orion year round.
Well, let me show you these. In fact, I don't even know if I could do it right now. Plus, I got to go, McToon. If I wasn't too misbehaved, man, I'd do it again, man. I'd prefer to do it on video, showing you, so I can show you things instead of just telling you.
Yeah.
But I had a good time, man. I wish you'd drop the condescending attitude a little bit, bro, man. I'll try and drop the outburst if you try and drop the condescending attitude.
We got some people talking about the swear jar.
Yeah. Shit, mine would be overflowing, but I'm just saying I wanted to know first if you thought it was a good debate. You know, that's why I asked you that first, because if you said no and flareters were stupid, I would have just left. I wouldn't even have debated you. You know, just want to have an honest discussion, a little bit of debate.
I think it's a lot of fun. So
I'm always trying to learn something new, man, and I'm trying to bring up some things that are, that are rarely discussed, if ever. You know, I got a couple more of them too that are, that aren't in the script. Let's save them.
Right? You said you needed to go, and we've left it open. We'll have another one in maybe, I don't know, several weeks or whatever.
All right, man. I had fun. I ain't gonna lie.
Let me see if there's, before we go to you, have a minute. I'll see if there's any super chats specifically for you.
Yep.
If they're nice, people, you got to be nice. Let's see.
I can take it I can dish it out. I can take it.
Let's see. Please ask him why every flight uses functional globe-based maps to navigate the world. I want to know his answer, given his claim to be open-minded.
That's one argument I can't stand. Okay, if you're going to map shit out using longitude and latitude, then you're mapping it out on a globe. Okay, if you look into, that'll be what we discuss next time, is the way we surveyed the states and shit.
Sure tells you something.
But if you map it on a globe, of course it's going to match a globe, right? Good.
Alyssum says Antarctica is currently hiring a lot of trade professionals, plumbers, carpenters, concrete layers. There you go. You could go work there for an Antarctic summer, just to to see if it's a globe.
Or you said Antarctica is hiring concrete contractors.
Trades, professions, plumbers, carpenters, and then I added concrete, like concrete.
I doubt that, dude. I mean, they'd have to add a whole lot of calcium in that shit, but I guess. But man, I don't know, man. I was just throwing out an idea how we could prove it earlier with Antarctica. That's always a good discussion.
All right, let's see. All right, well, that's everything that's specifically for you. So,
all right, brother, I'm out.
All right, thanks a lot, Brian, and I'll read some super chats here, people. All right, let me make sure I don't miss any here. Math is kryptonite. Studied calculus, profession. Can't cut out the middleman, and yeah, fly QF27. In the jar is moonshine extract. Yep, if you say so. If it was, and I'm drinking it like that, that's amazing. Conalex Silver Fur says for $2, how can you survey without math? And he had an S on the back of it, so I don't. Are you British, or where are you from there, Conalex, to have the math be plural like that? Microraptor's asking if I did the litmus test. I don't always do that. So, and he needed to get going here. He actually told me he only had an hour, and he's been here for 2. So I appreciate that at least. Lael for $2 says you need a Dyson sphere to contain a Dyson vacuum. That's right. I love that. In case you don't know, a Dyson sphere would be a sphere around the sun, and then you'd live on the inside, just like the concave earthers actually think people do. But I don't think it would work too well, because you'd have to rotate it to get to simulate gravity, and at the poles there wouldn't be much. So I don't know. Glober Mom for $5 says found a site about a marathon run in Antarctica that will have its 16th yearly race in a year. There are even videos on YouTube about it. Yeah, there are. There's also a bunch of flat earthers that think that at the North Pole there is a mountain. That they think there's a mountain at the North Pole, and that you can't go there. But of course you can. There is a marathon every year at the North Pole as well, and it actually goes like around the actual North Geographic Pole. They bring a boat up there, and you stay on the boat, and then you run around. I think you run in circles a bunch of times. So, in Canada, do you say maths in Canada? Interesting. So Bill Devitt maybe is saying that may be the case. Yeah, let's see. Punchy says, eat another ketchup chip for $2 No. $2 not enough for a ketchup chip anymore. I'm raising my rates. They're gross. They're really gross. Conoco Reasons for $5 says, destroy the ketchup chips. Somebody said, somebody posted on Facebook a picture and tagged me, a picture of ketchup candy canes. Gross. Oh, I don't like candy canes. I don't like peppermint much. I never eat candy canes. And a ketchup candy cane just... I like ketchup, but artificially flavored ketchup candy canes is just cannot be good. Alyssum for $5 says the Effie Clock app is a ripoff for the gullible. Also, Aussie here, the Effie app is incredibly wrong. It is. And you saw the prediction. It's the prediction from I used let's pull it up here and show you. There it is. I used 30 degrees south, 150 degrees east, which is kind of close to Sydney. Sunrise on the is that, yep, that's the December 21, 2018, or just the December solstice. 53 degrees north of due east is where the sun would rise, according to the flat earth map. And according to the globe, 27.5 degrees south of due east. And what is observed? Well, there it is. From suncalc.net, it is observed 28 degrees southeast. I was half a degree off. Half a degree. So, not bad for some Play-Doh and it wasn't a toothpick. It was a 14 gauge electrical wire, copper wire. So, Alyssum for 5 Australian says, ask him why every flight uses functional globe-based map. Yeah, I asked him that already. And that will be in the next showing of Brian Leakey. And gets agitated and then accuses me of getting agitated. Oh, yeah, listen, from Australia, notice he gets more and more agitated every time he gets called on his mistakes. I see someone can't handle being wrong. That is, I think he held it together pretty well. Conical Reason for 5 Canadian says MC Toon versus Brian, whatever is the name, whatever is the same as Mike Tyson versus a drunk flamingo. Brian makes me sad. Anna Lima Dominica Flatbed Autocorrect Haberdashery. Filling out the rest of the thing there. Kick-Ass Dave for £5 says, this is the problem with flirfs. They ask for answers, but they're only interested if the answer confirms their ignorant train of thought. That is it. The flirfific method is, number 1, decide on a required conclusion. Number 2, look for evidence supporting your conclusion, making sure to ignore any evidence that contradicts it. Number 3, declare that you have confirmed your conclusion. There you go. Make sure you put it on YouTube also. Kind of like Silver Fur for $2 says, funner isn't a word. I feel stupider. I think stupider isn't a word either. I like making up words. Funner is fine with me. I like it. Make up words all the time. Microraptor says, I joined late. Have you done the litmus test? No, I've not. Alyssum says, last one. Merry Christmas. Happy New Year. Thank you very much, Alyssum. And again, he said it was the last one and then did another one. Says, wait, North Pole Mountain, Santa's base discovered. Exactly. 2 years ago, I did a video on the flat earthers that were going to go to the North Pole. These are the blood over intent people, the Flat Earth Paradise and Quasi-Luminous. Quasi-Luminous is the guy who's like, he's from Florida too. He's nuts. He thinks that he has the spear of destiny. Yeah, the spear that punctured Jesus' side. He thinks he has that. He also says that he's Lucifer. And that if enough people do his blood ceremony, then they can all go to the North Pole and he can open up the portal to the underworld where paradise is with the spear of destiny and the people who have done the blood ceremony. They were going to do it in 2018. They didn't do it. Never happened. Anyway, I did a video on that and I told him, I'm like, this is like the movie Elf. So all you need to do is reverse Elf's direction that he got from when he went to the North Pole to New York City, right? Which was he went through the something forest and the swirly twirly candy canes. I don't remember. You just reverse that and you'd get to the North Pole. But no, they think there's a mountain there. Conical Reason. If your erection is quasi-luminous, consult your physician. Yes. Oh, try brushing your teeth with peppermint toothpaste and then eating a ketchup chip. No, that's gross. Just remember to check out Mark Steele's YouTube Lion Roars Triggering the PSYOP Brigade video. There could be grounds for several people to sue him into a black hole in space. He does Mark Steele thinks 5G is a weapon to kill people and also thinks that low power streetlight controllers that turn on and off. This little thing. He thinks that this little antenna 10 of these will literally vaporize somebody. He said that. You'll hear it tomorrow. He said that. Really. Like, there would be nothing left of you. It would disassociate all the atoms in your body. He really said that. Crazy. The name of that stream is Mark Steele's 12 Lies of Christmas. And the George said, got a 4x4 cube today. Have I ever tried to solve one? I have. I have it. I don't know where it is. I have it in the house here. I have a 4x4. I also have a 5x5 and a 6x6 and a 7x7 and an 8x8, but I don't know where any of them are. I kind of peeked out several years ago, and then they all got put away somewhere. I haven't had them for a while. So yes, Punchy personally messed up my 4x4 cube. So, oh, so what about Brian Leake? He held it together. I know he has a tendency to get really angry, and I was not trying to anger him, but how can you not chuckle a little bit when he's doing some of those things? So, well, that's it for tonight. 10 of those wouldn't toast bread. Electronics engineering technologist Bill DeVitt. Thank you. You're right. And it's funny because he points to these in a video. He points to this on top of a light pole. He goes 25 milliwatt, which is what this is rated at. This is what they reported to the FCC when they got FCC approval for this. 25 milliwatt. And then without pausing, he says, very powerful. 25 milliwatt, very powerful. No, 25 milliwatt is not very powerful. And its duty cycle is 0.1%. 0.1% of the time it can be transmitting 25 milliwatt at most. So I think at 1 centimeter, you're still within the safety guidelines. I think it's actually, no, I take that back. I don't know. I didn't do that math because it's in the near field, so it doesn't matter. Gary Wybenga is much worse to talk to. I've not heard Gary Wybenga talk. Where has he been online? Talking somewhere. He's commented on my Facebook stuff a little bit. He's on Facebook too. If Leake has a tendency to go berserk in 1 second, Gary Wybenga is much worse to talk to. Yeah, anyway, so that's tomorrow. It's 4 o'clock Central Time, 10 o'clock UK time. I'm really looking forward to it. Festive attire is recommended. I have a Santa hat I'll be wearing. Some of the other guys that are going to be joining us have, I think one of them mentioned he has an ugly sweater. So if you have an ugly sweater, you can wear it from home and celebrate with us. I did invite Mark Steele. I'm gonna put up the email I sent to Mark, because I'm sure, I mean, it was very polite. I'm sure he's gonna be excited to join us. So here we go. Good morrow. We're doing a Christmas special next Tuesday. It's actually Wednesday. Don't worry, I'll let him know that we changed the date. The title isn't set yet, but the working title is Mark Steele Christmas Special, His Biggest Lies Countdown. I changed it to the 12 Lies of Christmas. We will watch a montage of each of your lies and discuss. It will be great fun. Of course, you're invited. I'll send you a Zoom link, which I will. The purpose is to give you a chance to weigh in on your favorite ones. I don't want to leave any out. Well, he hasn't responded. I got my 12 of them picked, and I have a montage of each one. Attire is festive. An ugly sweater is a good choice. Christmassy hat is a good second. Be creative. And then no Christmas special is complete without Christmas music. I gotta zoom in so you see that. This is where you really get to shine. Could you do a little medley of your favorite Christmas songs? No more than 3 minutes, please. A cappella or with backing music, your choice. So there you go. That's the invitation I sent to Mark. I'm sure he'll come. Why wouldn't he come? Right. I'm glad glad you could all be here for this one. I see people saying that they're able to finally catch like Conical Reason could be here, and I appreciate that. Wait, on Mr. Sensible's channel, has Gary Wybenga been on Mr. Sensible, like on voice? That would, oh, I'm gonna have to go find that. Mark Beiser's wondering, how did I narrow it down to only 12 lies? That's a great question, because I had about 20 and I did have to pare it down. I'm like, it would get too long. And another reason why I had to do that was because some of them, I just couldn't find a really good like collection of things. Like he says that 5G causes that nasty virus that's going around. He does say that, but he doesn't say it in so many words that it made for a good soundbite to montage together. So I did not do that one. That was on the list, but I took it out when I was trying to actually like find bits to put in there. So, oh, Gary Wybenga was in chat, but he has been on Jose's channel quite a very good. Jose gets them. He gets the ladies come to Jose's milkshakes. Something like that. I'm not really up on that particular song. I might be misquoting it. Yeah, Sensible keeps trying, but Gary won't bite. I do the same thing. He won't. I don't know. So, all right, that's what I have for tonight. Thank you very much, everybody. I appreciate it. Thank you for the super chats. I love you so much. What I do, this is the highlight of my week is doing Tuesday night streams, and interacting with the chat. And you guys are awesome. You make it fun for me. If you weren't there, I would be much less interested. So this is awesome. Patrons and channel members, thank you very much. I appreciate what you do. It makes what I do so much more fun and worth it. Worth my time. And so if you want to do something, share it on social media, post this on Facebook or my other videos on Facebook. That kind of stuff is what really gets my channel to grow and makes it. I'm trying to break 10,000 subs, but the deal is Mr. Sensible and I are trying to hit 10,000 together, and I'm like, I gotta like slow down because he's a little behind me. So here's the deal. Go sub to Mr. Sensible if you haven't yet. And could the mod drop in, please, if somebody could grab his channel, Mr. Sensible's channel. He's fantastic. He's been very supportive of my challenges with Kim Drops, who has made some nasty allegations. But not going to get into that now. So Mr. Sensible's been extremely nice. So that's what I have. Be sure to come back tomorrow at 4 Central, 10 UK time for the Christmas special. So let me get the outro, and links don't work. What do you mean links don't work? There you go. There's 3, 4, 5 links to Mr. Sensible's channel. 6. You guys are awesome. Thank you very much for doing that. Go sub to Mr. Sensible. Seriously. He does great work and much better than I do. So anyway, everybody, we'll see you tomorrow. Merry Christmas.